All right, in this video, I am going to show you how to solve any quadratic. Okay? This method will literally give you the x-intercepts, also known as the solutions, also known as the roots, also known as the zeros, for any quadratic. Okay? So just to remember what the different methods we've been looking at, okay? We've had factoring. We've also looked at completing the square. There's a third option called graphing. You can actually graph the quadratics if you know where the vertex is, but that's not something y'all do in 8th grade or in algebra actually, so we're not gonna worry about this one. There is a fourth method, and this is a method most people remember from their days in middle school and high school. It's called a quadratic formula. There's actually a formula, sort of like an equation, where you legitimately just plug in values and it tells you what the answers are. Okay? Now, I'm debating right now, do I just tell you the formula so we could use it, or do you want to see where it comes from? All right, remember that time I told you, well, the slope is, y2 minus y1 over x2 minus x1. I think I showed you how we came up with that formula. Now, some of you were like, oh, that's pretty cool, and now I know where it comes from. And some of you were like, I don't care, I just want to know what the formula is. I'm being a math nerd right now. I'm going to actually show you where the quadratic formula comes from. I'm not even going to tell you what the formula is. You're going to see it for yourself, okay? So this is one of my favorite proofs. I mean, this is a proof. Y equals ax squared plus bx plus c. I had to do this when I was in college. I actually had to show my class how to come up with the quadratic formula because it's a staple. It's one of those things where, like, if you don't know how to do it as a math college student, as a math major, like, you need to switch majors, okay? So I am going to show you the quadratic formula, derivation. Derivation meaning how we find it. So obviously we're trying to solve a quadratic, right? We leave it in standard form. So we're going to set the quadratic equal to 0. Now, to make things a little bit easier, I'm going to move the c over to the left. And remember, this is a quadratic, so, it probably makes sense. We can't factor it, so it makes sense to complete the square on it. I'm going to divide everything by a. And we can do that since a is not equal to 0. So we have negative c over a is equal to x squared plus b over a x. If this starts getting confusing, that's okay. A lot of people never come to fully understand completing the square or even this. You don't have to know how to do this. But if you can follow along and sort of like make sense of it, that's awesome. So now I want to complete the square, okay? But, we're not using numbers. So like, how do we know what we need to add to complete the square? Well, remember, you're always going to take the middle term, which in this case, let me highlight it, is b over a. And remember, you're going to take the middle term. You're going to divide by 2 and then square it. That's how you know what you need to add to complete the square. Now, when we divide by 2, that's the same thing as multiplying by a half. Okay? So this is b over 2a squared. So that's just b squared over 4a squared. So we need to add b squared over 4a squared to both sides of the equation. I'm going to zoom in here so I can fit. B squared over 4a squared. Whee! And since I added b squared over 4a squared, I also need to add it to the left side of the equation. Now, the right side of the equation is just going to be, right, since we've completed the square, this is a perfect square. this is going to become x plus b over 2a. Now you might be wondering, why is a 2 in the denominator? It's just b over a. Well, remember, whatever the square is, right, whatever the middle term is, you have to cut it in half. If it was a 6, it becomes a 3. If it's a 10, it becomes a 5. So you just take half of whatever the middle term is. In this case, it's b over a, so half of it would just be b over 2a. Now the left side looks a little messy, so let's clean it up. And by cleaning it up, I mean having common denominators, right? Here we have a fraction that has a 4a squared on the left, and we just have an a on the right. So what I need to do, right, whenever you add fractions, you need common denominators. I need to multiply this by a over a, so now I have that a squared, but I also need to multiply by 4 over 4. So now we have common denominators. Here we have b squared minus 4ac all over 4a squared. Now that we have the left-hand side sort of simplified, and we also have the right side in perfect square, we can now start solving. Now, what I'm about to highlight right now, this part right here, that's just a number, okay? That is just a number. I know it looks really messy, but if you had a quadratic a, b, and c, right, a, b, and c are numbers, and you were to plug in the numbers into this little thing, b squared minus 4ac all over 4a squared, that would just give you a number, okay? So don't get confused here. That's just a number. So if you were to take the square root, it's just the square root of a number, okay? So we're going to take the square root of both sides. On the right side, we're going to have x plus b over 2a. And on the left, well, you're going to take the square root of that thing, but I'll help you out. When you take the square root of a fraction, remember, you can take the square root of the numerator and the denominator separately. So what we have here is just the square root of b squared minus 4ac. And in the bottom part, well, it's the square root of 4a squared. The square root of 4 is 2. And the square root of a squared, well, what do you have to multiply so you can get a squared? A. Now, once again, I'm going to highlight all of the things that are a number. b over 2a is just a number. The square root of b squared minus 4ac over 2a is just a number. So, these are just numbers. We're solving for x. What do you have to do to solve for x? You subtract b over 2a. Remember, b over 2a is just a number. So we're going to have b over 2a. Oh, you know what? There's a little mistake right here. Well, not a mistake, but remember I took the square root over here of a square, which means, and let me use a different color. This should be plus or minus now. Plus or minus. So here we're going to have negative b over 2a, right? Because we subtracted negative b over 2a from both sides. And then we're going to have plus or minus the square root of b squared minus 4ac over 2a. And that should be equal to x. Right, this is a 0 here. We're going to cancel it. So really what we have is x is equal to negative b. Now remember, it's the same denominator. So I can combine it into one big old thing. Plus or minus b squared minus 4ac, everything over 2a. And what if I were to tell you this is a quadratic formula? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm sure you've seen this before. Let me rewrite it again because it's such a beautiful formula. B squared minus 4ac all over 2a. This formula, a lot of people, this is the only thing they remember from quadratics. And it makes sense because with this formula, you can always find the answers. There's no need to factor. There's no need to, no need to complete the square. If you can remember this formula, you can always find the solutions to a quadratic. It's amazing. Okay? So now that we've seen where the formula comes from, we can actually use it. And, you know, maybe you'll pick up on this. This portion right here, the stuff that's under the square root, that will tell you whether you're going to have two solutions, one solution, or no solution to the quadratic. If you're taking the square root of a positive number, right, if b squared minus 4ac is a positive number, that means the quadratic is going to cross 2 times, meaning it's going to have two solutions. If b squared minus 4ac is equal to 0, you're only going to have one solution, right? Because when you take the square root of 0, that's just 0, so you're not going to have a plus or minus. And what do you think happens when whatever's inside the square root is negative? Do you think it's going to have any solution? Of course not. You're taking the square root of a negative number. You can't do it. And just like in the last video where you had, you know, an example of where you took the square root of a negative number, that's exactly what's going on here. You can't take the square root of a negative number. But let's try it. Let's use an equation, y equals, I'm gonna pick one that's factorable, okay? Y equals x squared plus 4x plus 4. This is factorable. Two numbers that multiply to 4 and add up to 4, 2 and 2. So I know I can write this equation, y equals 2, I can write this x plus 2 times x plus 2. So already just by looking at this, we can tell that the solution is going to be x equals negative 2, twice, right? Meaning this only has one solution. But let's try using the formula just to see, okay? A is equal to 1, B is equal to 4, C is equal to 4. So the quadratic formula is always write the formula first. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And now what you're going to do is, you know, this might help some of you. We have an a right here. We have an a right here. B, 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 and then C. Okay, we're going to replace all of these values with their respective numbers. So we're going to have negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4 all over 2 times 1. So we have negative 4 plus or minus the square root of 16 minus 16 over 2. Negative 4 plus or minus the square root of 0 over 2. It's negative 4. The square root of 0 is 0, so negative 4 plus 0 is 0. It's negative 4 over 2, which is negative 2. So x is equal to negative 2. And sure enough, look, x equals to negative 2. Let's do one where you can have two solutions, okay? That means that I have to pick a problem that has two solutions. And I want the numbers to be small, so let's do y equals, x squared plus 5x plus 6. So the first thing you gotta do is identify what a is, what b is, and what c is. And you're gonna write out the formula. Now if you're listening, you might remember the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song to it, and trust me, it'll help you remember it. So I'm going to go ahead and color code these. A, and there's another A here. I almost forgot. B, B, B. C, C. In my past years of teaching, I always found students they don't know how to plug in the values. That's where they run into issues. So you should focus on practicing that skill, okay? So we're going to plug in the numbers. X is equal to -5 plus or minus the square root of b squared. So that's going to be 25. I'm skipping the 5 squared part, okay? Minus 4 times 1 times 6 all over 2 times 1. So now I have x is equal to -5 plus or minus the square root of 25 minus 4 times 6 is 24. So 24 all over 2. So this is going to be -5 plus or minus the square root of 25 minus 24 is 1 all over 2. The square root of 1 is 1. So we have a plus or minus 1 over 2. Now, when you get to this point, here you have two different possible answers, right? You're going to have -5 plus 1 over 2 and -5 minus 1 over 2. -5 plus 1 is -4 over 2, which is just -2. Here, let me actually write the equal signs. And then -5 minus 1 is -6 over 2, which is -3. So the two solutions are x equals -2 and x equals -3. So this quadratic crosses 2 times on the x-axis. And if we look up here, this quadratic, if you think about it, oh, my pen's almost not working. What two numbers multiply to 6 and add up to 5? 2 and 3. So we know this would factor as y equals x plus 2 and x plus 3. And if you were to think about it, what does x have to be so that it equals 0? -2. What does x have to be so that it equals 0 on the second part here? -3. The quadratic formula will always tell you your solutions. I want to do 2 more examples just to show you that it works, and you're going to get a chance to try this out, okay? So let's try y equals x squared minus, or let's do plus 3x plus 10. Now, I'll tell you this for a fact, this is one of those quadratics that is not factorable, okay? There is no two numbers that add up to 10 or add up to 3, multiply to 10 or add up to 3. We can't think of any whole numbers, right? Like 2, 7, 10, 3. But it is entirely possible that there are decimals or or irrational numbers that have those properties, and the quadratic formula will tell us that. A is equal to 1, B is equal to 3, C is equal to 10. So we're going to set up the formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. If you're wondering what the tune is, it's Pop Goes the Weasel. That's the tune I'm singing it to. So let's go ahead and just plug in these numbers. So we're going to have, I'm going to go over here, x is equal to -3 plus or minus the square root of 3 squared minus 4 times 1 times 10 all over 2 times 1. So we're going to have -3 plus or minus the square root of 9 minus 40 all over 2. Almost immediately right here, you can tell that this is not going to have any solutions, because you have a 9 minus 40. That's a negative number, which means you're going to end up taking the square root of a -31 over 2. So immediately right here, since you're taking you're taking the square root of a negative number, you can say no real solutions. And you just stop. You can just stop here. The reason it has no real solutions is because, well, you're taking the square root of a negative number. Let's do one more. Y equals x squared plus 9x plus 2. So if we were to try to factor this, right? Always try factoring. That's my thing. Always try factoring. Factoring is honestly the fastest. Once you get really good at factoring, it's faster than the quadratic formula. But if you want to be correct for sure, use a quadratic formula, assuming you know how to plug in the numbers. So a is equal to 1, b is equal to 9, and c is equal to 2. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in the values here. And actually, before you even start plugging in the values, if we go back to the original quadratic, what two numbers multiply to 2 and add up to 9? You might think it's impossible, but watch. So, negative b, so that's negative 9, plus or minus the square root of b squared, so that's 81, minus 4 times 1 times 2, that's going to be 8, all over 2 times 1, which is 2. I'm getting real lazy with plugging in all the numbers. Negative 9 plus or minus the square root of 81 minus 8 is 73 over 2. This becomes two problems, or two answers. X is equal to negative 9 plus the square root of 73 over 2, or negative 9 minus the square root of 73 over 2. Now, on your calculator, you can try figuring out what the square root of 73 is. I know 73 is between the perfect squares of 8 and 9, so it's going to be 8 point something, and I personally don't know. So the two numbers here are going to be like negative 9 plus 8 point something. Obviously, I don't want y'all writing this on your assessments. Please don't. Or negative 9 minus 8 point something over 2. But here's the weird part, okay? These numbers are both going to be, first of all, they're both irrational, okay? They're going to be irrational because obviously you can't write these as fractions. The decimals they don't have a pattern and they're going to go on forever. But these two numbers, this is a number. Let me use a different color. And this is a number. These two numbers have the special property, right? They have the special property if you don't convert them to a decimal. They have the special property that if you were to multiply these, it equals 2. And if you add these numbers, it equals 9. I know it sounds really weird, but these two numbers in green and gold, if you were to add them, it equals 9. And if you were to multiply them, it equals 2. So I know in my earlier videos, I said, oh, this is not factorable, therefore it can't have any solutions. What I really meant to say was, oh, this is not factorable, therefore we're not going to have integer solutions. We're not going to have answers or roots where the numbers are whole numbers. We will have roots, but they're just going to be really messy. That concludes the last video for quadratics.